So we covered the secret of longevity, which is the heart and brain coherence. And today I want to cover the science of longevity. So the science of longevity is very much also connected with breathwork and meditation. So, first time when I learned in 2002 the breathwork, it was by a master called Leonardo Orr, and he called it rebirthing. And he said every breathwork is like rebirthing of your new self. It's like it's every breathwork is a rebirthing, and he said you can reverse your age and everything. So I asked him, how does this happen? Of course I feel good, I'm feeling very relaxed, but how do you say that the age is getting reversed? So he said that before he discovered this breathwork, his mission was to study the immortals, or to study the people who are living long. And he stayed with 12 masters who lived for more than 300 years. 12 masters. And in his book, he has written by Leonardo Orr, I don't remember the name of the book, but if you see, the author is Leonardo Orr. And in that book, he has described all these 12 masters and his journey with them. Few of them, just a minute. Few of them are Indian masters and Himalayan masters. He lived with them, and there's one thing which he found common between all of them is how do they is this breathwork technique which he shared with us. That everybody practices a common technique is they all practice breathwork, and there could be a little bit difference of the techniques, but what he took the technique was a combination of all of them, and that's what he incorporated in this technique, which I'm sharing with you all, right? And then I did my own research on the science of longevity. So the research shows that there are three things which are three biomarkers. How do we scientifically know that after meditation or after my breathwork session, my age is actually reversing or not? How do I know it biologically? I mean, you may say you feel young, you may feel good, but unless I wanted to know the scientific research. So I'm going to share with you that research, that understanding about what are those biomarkers. And then I'm not going to share you the whole, what are the tests we have done on people doing breathwork. We don't want to go much into that. But what is the science? What is the scientific biomarkers of longevity? I'm going to share with you because a lot of new research is being done on this. And this whole is in the last 10 years, so much research has done on these subjects. And before that, people were not even aware of it. And and more you're going to learn more about it, more and more medical technologies are going to come, medical discoveries are going to come in this dimension. So it will be good for us to understand this subject better, right? And I promise you today is the last day of all the scientific knowledge or understanding that I'm bombarding on all of you. So no more physics after today, no more chemistry, no more biology. Then we'll go more deeper into the subjects of consciousness or relationships, right? So today is the last day. So just bear with me for next 30 minutes, and then we'll go into the breathwork session.
Shreans, you're too modest. We couldn't get enough of it. Even the science and the physics, it's so fantastic. Please go ahead. Sorry.
Thank you. Right. So let me share with you the science. Yes. So we are as you know that we are a pure human technology, right? We are the technology that we've been looking for. We know how miraculous our body is, how our body is a miracle machine. So we are wired to self-regulate or regenerate. It is very important. We are wired to self-regulate or regenerate our telomeres, stem cells, and hormones for longevity. And these are the three main important factors, biomarkers, where we can test whether your age is reversing or your age is more than your biological age. Sometimes people are 40 or 50 and they're looking like 70 and 80, right? So even though your biological age is less, even though our biological age is less, but our chronological age, the age from our date of birth, which is in this three-dimensional time frame, our age is much more, right? So, or vice versa, or we are our age is more, our biological age is looking like 80, but we are looking like 50. So there's a difference between biological age and chronological age. Biological age is what is your body saying? How youthful are you? Right? And chronological age is common for everyone. It is just calculated from your date of birth. Right? So you know how people sometimes, if they're meditators or breatharians or breathworkers or people who are looking a very balanced, relaxed life, they look young. They always look younger than their chronological age. And those who are looking very stressful life, after a period of time, age starts showing on their body, right? They even at the age of 50, they look as if they are 70, right? And this can be measured scientifically nowadays. And there's so much of research being done on this. So what are the three main important factors which are the biomarkers for testing this? So one is stem cells, second is telomeres, and third is hormones. And one by one, I'm going to talk about all these three factors: stem cells, telomeres, and hormones, which you can measure for our longevity. So first is stem cells. Keshav, you can share the slide. So friends, when we are born, we are born with a complement with full complement of stem cells, right? So what are stem cells? So I've told you we have 50 to 70 trillion cells in our body, and 25 million cells die every second, and 25 million cells born every second. But in this 50 trillion cells, there are few cells which are called stem cells. And these are the stem cells which leads our body into growth, repair, or these are the stem cells are responsible for tissue growth, and eventually our muscles, and eventually the organs. So what you see as our lungs, or as our digestive system, or endocrine system, our cardiovascular system, all this system, or different organs of our body, like our liver or pancreas, all have grown from stem cells. So only the stem cells grows into tissues, not all cells. Not 50 trillion cells grows, only the stem cells grows into tissues. And that's why stem cell is so important. And nowadays, in last 10 years, so much of research has done on stem cells. So much of therapies are being developed on stem cells. As soon nowadays, whenever a new baby is born, we actually take the stem cells from the placenta and store it and freeze it. Right? There are so many labs who charge money and freeze the stem cells, so that later on, any time of your life, of the life of that person, if they need to, if any tissue or organ is damaged, you can inject the same stem cells when you are born, and you can regenerate or regrow that organ. Isn't this amazing? So that way, science has done remarkable discoveries, remarkable growth in terms of longevity. And when we have seen in the lifespans has been really growing in last 100 years, right? So and now they say so much of research is going on, and they are predicting that in next 20 years, everybody should be living more than 100 years. 100 years should be a norm. So what are these stem cells? I'll go in more detail. How many stem cells as we grow? Keshav, you can share the slide. So as we grow, the stem cells, the number of stem cells in each cell, the ratio keeps on decreasing. So what happens is, when you're newborn, out of every 10,000 cells, one cell is a stem cell, right? So because you need a better ratio, so that is the time our body goes into growth mode, right? So all that is the time when our bodies, all the organs grow. As you become a teenager, it reduces from 1 lakh cells to only 1 cell. So divides by 10 times, it reduces, the ratio reduces. At the age of 30, only 1 out of 250,000 cells are stem cells. At the age of 50, only 1 out of 4 lakh cells are stem cells. At the age of 80, only 1 out of 20 lakh cells are stem cells. That's why, as a norm, it becomes any tissue or organ gets damaged, it becomes challenging to repair it because you have much lesser stem cells in your body compared to when you were born, right? And that's why we are not able to regenerate or regrow any organ. Now, the new discoveries, and this was the belief system which was there until 10 years back, not too long, right? Until 10 years back, they thought that this is fixed, this cannot be changed. Every human being has the same, this is very generalized information. Every human being has more or less similar to that. Now, the new science, as the method of research and the equipments, and we had better discoveries to measure these stem cells, now they found that not all cells decline, not all stem cells decline with age. The number of stem cells may not decrease with age as believed. This is so important. The number of stem cells may not decrease with age as believed. So it all depends on your environmental factors, So during the workshop, or during the class on master class on healing, I had on epigenetics. Remember, I had discussed about the environmental factors, your thoughts, your emotions, your food, the pollution, the kind of place you live in, your relationships, your family, your house, your office, your work environment. Everything has the kind of organic food, inorganic food, 2G waves, 3G, 5G, the pollution in the air. So all that has an influence on our, all that combines the environment, and that has an influence whether the stem cells may decrease with age or may not decrease with age. So it's the ability of the stem cells to fully express that may decline with age. So two things happen. Either the stem cells may decrease with age, or even if the stem cells may not decrease with age, their ability to fully express may decline with age, right? So even their expression depends on the environmental factors. So if somebody is born twins, two brothers are born twins, even then, at the age of 50 or 60, you may find different, the total number of stem cells could be so different, depending on their lifestyle. Even if the stem cells, and even those stem cells, their ability to express itself, their ability to fully express may also differ. So two things, one is quantity and second is quality. Both can vary between individual to individual. Right? Even the science now proves that even the older stem cells are capable of awakening and renewable. And something that makes it really possible is breathwork and meditation. These are two powerful tools to really not decrease the stem cells with the age, or not decrease their ability to fully express with age. And even if they have decreased, or even if they're not fully expressing, even at the older age, so stem cells, again, remember, stem cells cannot be reborn. If they have reduced, they'll stay reduced, unless you inject them externally, which is possible now. But the older stem cells, which is not able to express fully, the remaining stem cells which are not able to fully express, are capable of awakening and renewable. So which is our human potential now. At any time, you can change your ability of your stem cells to express. And in future, the moment you start changing environment, your lifestyle, your thoughts, your emotions, at least in future, you will slow the division of your stem cells. So I'm going to share one more slide. So there are three types of stem cells. It is very important to understand this. There are three types of stem cells. First type is called embryonic stem cells. Embryonic cells, which can become any cell of the body, any part of the body. So they are also called pluripotent stem cells. So they are very potent, and that can with the same cell, and it can turn into any part of the body, any tissue of the body, which makes the part of the body, right? You know how cells makes tissues make muscles, and muscles make that part of the body, and that part of the body together make those organs together make the systems of the body. So this cell, when you are born, this pluripotent cells can become any cell of the body, right? And the other cells are called adult stem cells. So these stem cells are only specific to certain tissues. So certain specific stem cells can only become those specific parts of the body, right? So their ability to express is much lesser compared to the pluripotent cells. Now, this third part is very important to know. So there's another kind of stem cell. Another stem cell is called induced pluripotent stem cells, which is also called iPSC treatment. So when you are born, nowadays, when the baby is born, it is recommended to store the stem cells from the placenta, right? So what happens is, at any stage of life, if the child is going through, if that person has grown up and going through any kind of health issues, these pluripotent stem cells, which were taken when they were born, can be induced in them. And now that can become any cell of the body. Isn't this amazing? That we have now the science has helped us to grow and repair any part of the body at any stage of our life. So we are born with a full complement of stem cells. Now, stem cells are believed to live in a dormant state in specific places in the tissue until they are activated through injury, stress, or disease. So you know how we have a propensity to heal ourselves, right? We are wired to heal ourselves. So anytime our body goes through any disease, or you are going through any traumatic stress or any kind of injury which has damaged the tissues of your body or that organ, immediately the dormant stem cells, the stem cells usually lie dormant, because now once your tissues are grown, you don't need further growth, right? So it stays dormant. But anytime there's an injury, stress, or disease, it will become active, because it has to regenerate, it has to function, because it needs to repair that organ of your body, repair that part of the body. So don't worry. Anytime you're going to any disease, injury, stress, your stem cells becomes active and they can repair you. They can heal you, right? And as I told you, the actual number of stem cells varies from each person. It is not a fixed number. Earlier, it was believed that it was a fixed number, but now they found that each person varies depending on their lifestyle. Now, the adult stem cells have been found in many tissues, including the brain, bone marrow, blood vessels, skeletal muscle, skin, teeth, heart, gut, liver, and others, but not all tissues. But main important tissues like brain, heart, blood vessels, our gut, all these are skin, all these adult stem cells have been found in all these tissues. So anytime you can regenerate these parts of your body because the adult stem cells are there, right? So this I shared with you the biology of regeneration, how stem cells may become other cells, right? So this is the pluripotent stem cells, which is also called embryonic cells. They can cells can become bone, same can become heart, liver, or intestines and brain, or any other parts, right? So far clear about the stem cells?
Yes, Shreans, completely.
Lovely.
Very clear.
Yeah. So now I'll go to another part of our other biomarker, which is other than the stem cell, is telomeres. And why I'm sharing this information, because as you will find more and more of these words, researchers in the medical fraternity, and a lot of treatments will be based on these. So it is good to know to make the right, so that you can take a right choice at the right time, so that you have basic understanding of what all these things are, right? Like how epigenetics, now you totally differently think different when any doctor says, oh, your disease is hereditary. Now you think very differently, right? You don't give in to the belief of the doctor or what doctor is telling you, because only 1% is hereditary. 99% is epigenome. It is about genetics, right? It is about the genetics. Now in the nuclear of your cells, if you have 50 trillion cells, and every cell has its own nucleus. It's like in the center of the cell, there's something called the nucleus of the cell. Now, in the nucleus of the cell, there's something called chromosomes, right? Chromosomes, the chemical which makes the chromosomes are chromatin. So I'm not going to go into detail of the chemical part, but these chromosomes are actually coiled with your DNA, which you get from your parents. This is coiled with your DNA. So this is the chromosomes, this is the shape of the chromosomes, and they are coiled with your DNA. And at the tip of the chromosome, there's something called telomeres, right? So this is how the DNA coils. This is the shape of the DNA, and this is how the DNA coils your chromosomes, right? So it's like wiring. It's like a wiring on the chromosomes is of DNA, right? And it is the DNA which expresses itself. And I've told a lot about DNA or genes, which you call how it gives expression because of the environmental factors. So now I'm going to talk about telomeres. So you can see telomeres are like, on top of a shoelace, on the tip of a shoelace, how there's a plastic cover. Similarly, on your chromosomes, at the tip of your chromosome is called telomeres. And now, so you can see here, this is the tip of the chromosome, and now what the scientists have found, that as you age, the size of your telomeres starts reducing, starts decreasing. And as a normal human being, your telomeres, how many times the telomeres divide itself? By 40 to 60 times. So every time it divides itself, every time the telomeres divide itself, its size reduces. So normally, according to the scientists, you should normally be able to live, depending on how the telomeres divide itself. Every normal human being, if they live a normal, natural, healthy lifestyle, they should be living for 120 years. So this is how we are biologically programmed to live for 120 years. So 120 years should be a norm. But because of our unhealthy lifestyles, because of the environmental factors, we biologically age faster, and that's why we are not able to live. So this is the scientist. Scientist's name was Hayflick, and that's why it's called a Hayflick limit. So telomeres, usually the divisions are limited to 40 to 60 divisions in the whole lifespan. And that's why, according to that, they predicted that we should be able to live for 120 years of linear aging. Right. So telomeres length, as I've shared with you, the length always declines as the dividing cells. As we age, the cells start dividing, and with every division. So initially, if the cell was, if the length was of 8,000 is a biomarker called telomerase, which I'm going to share with you in the next slide, in the next two slides. Telomerase, the number of telomeres starts reducing, and that leads to it's an enzyme in the telomeres. Its name is called telomerase. And as the enzyme starts reducing, with every division, the enzyme starts reducing, and that's why the length of the telomeres starts reducing. Right. So initially, when you are born, it is around 8,000. As you start aging, it starts reducing. Right. So this is how this is the telomeres. So initially, as the cell divides, right, the telomeres first division. This is the size now. So earlier the size was longer. Now it reduced. Another further division, as it divides itself, again the size starts reducing, right? So there was a research done by three physicists, and they were given a Nobel Prize. In 2010, they were given a Nobel Prize in the field of physiology and medicine. And the three physicists' names were together. They were given the Nobel Prize because this was a research done jointly by them. So they discovered an enzyme in the human body, right? And these scientists were Carol Gradier, Elizabeth, and Jack. So